This video explains the differences between minerals, ores, and rocks, ensuring clarity and understanding. What is a mineral? A naturally occurring inorganic substance that has solid state at room temperature, a more or less definite chemical composition representable by chemical formula, definite atomic structure, ordered internal structure. The mineral halite has a chemical composition of sodium chloride. This means it contains equal numbers of sodium and chloride ions, arranged in a cubic pattern that repeats in all directions. Rocks, ores, and gems. Rock can be an aggregate of minerals or non-minerals, organic substances. Does not have a specific chemical composition. Ores, concentrations of minerals in rock that are high enough to be economically extracted for use. All ores are minerals, but all minerals are not necessarily ores. For example, cinnabar, HGS, is an ore of mercury, sphalerite, ZNS, is an ore of zinc, and cassiterite, CnO2, is an ore of tin. Gems, minerals with an ornamental value, distinguished by their beauty, durability, and rarity. For example, diamond and ruby. Examples of rocks, ores, and gems. 1. Rock, vein gold, vein quartz with gold attached to basalt from California. Second ore, cinnabar, HGS. Hardness, 2 to 2.5. Specific gravity, approximately 8.1. Formula, HGS, mercury sulfide. Crystal system, trigonal. Third gem, diamond. Hardness, 10, the hardest mineral. Specific gravity, 3.6. Formula, C, carbon. Crystal system, isometric. Mineral classification. About 5,000 minerals are known, divided into two major groups. 1. Rock-forming minerals, abundant in the Earth's crust, for example, quartz, feldspar. 2. Ore-forming minerals, have economic value but are rare. For example, iron, aluminum. Native elements, minerals composed of atoms from a single element, total of 9. For example, arsenic, As, gold, Au, silver, Ag, copper, Cu, diamond, C, graphite, C, sulfur, S, platinum, Pt, and bismuth, Bi. Classification of rock-forming minerals. 1. Oxides. The example of these minerals are quartz, magnetite, lodestone, hematite, and limonite. 2. Carbonates. Carbonates may exist in the form of calcite, CaCO3, calcium carbonate, dolomite, and siderite. 3. Sulfides. Some of the sulfides are pyrite, galena, and sphalerite. 4. Sulfates, for example, gypsum. 5. Chlorides or halides, like rock salt. 6. Silicates. Some of examples of silicates are feldspars, mica, hornblende, augite, and olivine. Classification of rock-forming minerals. A. Oxides. Minerals in which oxygen is combined with one or more elements. Due to the abundance of oxygen in the Earth's crust, these minerals are very diverse in physical properties. Hardness, from quite soft, H equals 5, to very hard, H equals 9. Color can range from black to very colorful. Examples: quartz, SiO2, magnetite, ferric oxide, hematite, ferric oxide. 2. Carbonates. Formed when carbon atoms join with oxygen to form the carbonate ion, CO3, which then combines with other elements. Transparent, and lightly colored with a white streak. Soluble in acidic solutions. The examples are calcite, CaCO3, dolomite, calcium magnesium bicarbonate, and siderite, FeCO3, which are shown below. 3. Sulfides, composed of elements with sulfur. High densities. Exhibit electrical conductivity. Black or dark-colored streak. Often formed in igneous environments. The picture of sulfides in the form of pyrite, FeS, galena, PbS, and sphalerite, ZNS, are shown below. Sulfates. Sulfates are the combination of SO4 with other elements. Its properties are: it have average hardness. In some cases, it is soluble, have vitreous luster. In several cases, it is fluorescent. Chlorides or halides. The minerals that make up the halide class include those in which the halogen elements of chlorine, bromine, fluorine, and iodine are combined with one or more metals. All minerals of the halide class following properties like cesial, it have relatively low hardness. It can be transparent. It have low specific gravities, sound and have good cleavage. It may poor conductors of heat and electricity. The examples of halides are carnallite, cryolite, fluorite, and halite, sodium chloride. Silicates, the most common minerals, making up over 90% of the Earth's crust. Minerals of this group are formed by the combination of SiO4 with other elements. Examples: A. Feldspars, B. Mica, C. Hornblende, D. Augite, E. Olivine. Properties and identification of minerals. Optical properties. The correct identification of minerals is made with a polarizing microscope. Physical properties are color, streak, luster, hardness, cleavage, fracture, form, specific gravity, tenacity, odor, feel, fluorescence, phosphorescence, magnetism. Properties and identification of minerals. Color. The color of a mineral is that seen on its surface by the naked eye. Some minerals possess a characteristic color, for example, the lead gray of galena, the black of magnetite, the green of chlorite. Some minerals, such as quartz and calcite, have variable colors when seen from different directions. This is called play of color. The reasons for this include isomorphous variations in compositions, minute colored inclusions. The term opalescence is applied to minerals that have a milky appearance, such as opal. When bands of prismatic colors are seen on the surface of a mineral, it is said to show iridescence. Color can't be the sole identification property. Examples of color in minerals: galena, magnetite, chlorite, opal. Streak. Streak is the color of a mineral powder. The minerals are rubbed against an unglazed porcelain, ceramic plate, also called a streak plate, to observe the color of any mark left. In some cases, the color of streak differs remarkably from color of the mineral, like pyrite is brass yellow but has a dark green streak. Luster. The appearance of the mineral surface in reflected light. It shows the quality and intensity of light reflected from the surface of a mineral. It is a measure of how shiny and smooth the surface of a mineral is. Various types are: 1. Metallic, strong reflection, luster exhibited by metals, for example pyrite, galena. 2. Vitreous, exhibited by the broken surface of glass, bright, shines like glass, for example quartz. 3. Resinous, a resin-like shine, resembling amber for example, shines like the surface is covered with oil. 4. Greasy, a dull sheen, has the appearance of being coated with an oily substance. 5. Pearly, a whitish iridescence, resembling pearl for example. 6. Silky, a sheen like that of a fibrous material like silk for example, asbestos. 7. Adamantine, a brilliant luster such as that of diamond. 8. Dull or earthy, like the surface of unglazed pottery. Hardness. The hardness of a mineral is its resistance to scratching. It is determined by comparison with the standard minerals of the Mohs scale of hardness. Mohs scale of hardness was created by a German geologist, Friedrich Mohs, in 1812. In this scale, 10 minerals are arranged in order of their increasing hardness. A mineral can scratch minerals with a low number, but not minerals with a high number. Cleavage, the property of minerals to break more easily with smooth surfaces in certain directions. These directions lie parallel to the actual or possible crystal faces of the mineral. Cleavage is related to the atomic arrangement within the mineral. Galena has 3 cleavages at right angles forming cubes. Mica cleaves in one direction only. In calcite, cleavage planes meet in acute and obtuse angles, giving a rhombohedral form. Quartz has no cleavage. When minerals break with ease, producing smooth, lustrous faces, they are said to have perfect cleavage. Inferior degrees of cleavage are described as good, distinct, indistinct, and imperfect. Fracture, the nature of a broken surface of a mineral in any direction other than cleavage. Unlike cleavage, fracture does not produce smooth planes. Types of fracture: 1. Uneven fracture. When the broken surface is rough or irregular, for example, apatite, a group of phosphate minerals. 2. Even fracture, when the mineral breaks with a flat surface, for example, flint. 3. Conchoidal fracture, when the mineral breaks with curved surfaces, often with concentric markings like a shell, for example, quartz. 4th, Hackley fracture, when the broken surface has small sharp irregularities like broken metal, for example, native copper. Form or habit, defined as the size and shape of the crystal. Minerals may occur either in the form of well-developed crystals or as massive, without the development of recognizable crystals. Crystal, a solid substance with a definite atomic structure. Important forms are acicular, minerals showing needle-like crystals, for example, natrolite. Fibrous, minerals showing an aggregate of fibers, for example, asbestos. Columnar, minerals which occur as columnar crystals, for example, tourmaline. Bladed, minerals showing this form occur as small knife blades, for example, kyanite. Foliated, minerals having thin separable lamellae, for example, mica. Botryoidal, minerals showing an aggregate of spheroidal masses resembling bunches of grapes, for example, chalcedony. Reniform, minerals showing kidney-shaped forms, for example, kidney iron ore, hematite. Granular, minerals which occur as an aggregate of grains, for example, chromite. Tabular, minerals showing broad flat surfaces, for example, feldspar. Pisolytic, minerals which occur as an aggregate of rounded grains of pea size, for example, bauxite. Oolitic, minerals showing an aggregate of bodies resembling fish roe, where the rounded grains are the size of a pinhead. Specific gravity. It is defined as the ratio of the weight of a mineral with the weight of an equal volume of water. Low RO from 2.2 to 4.0, including silicates, carbonates, sulfates, and halides. Medium RO from 4.5 to 7.5, including metallic ores such as sulfides and oxides. High RO greater than 8.0, including native metallic elements such as pure copper, gold, and silver properties, and identification of minerals. Tenacity, the property of minerals that describes the behavior of a mineral under deformation. It shows the degree of cohesion of a mineral amongst its elements. It describes the physical reaction of a mineral to externally applied stresses, such as crushing, cutting, bending, and striking forces. Different forms are 1. Ductile. Some minerals can be drawn out into a thin wire without crumbling. 2nd, sectile, minerals which may be cut with a knife into slices, but slices are not malleable. 3. Malleable, minerals which flatten under the hammer. 4. Flexible, minerals which may be bent. 5. Elastic, minerals which spring back after bending. 6. Brittle, minerals which break easily. 7. Friable, minerals which crumble easily. 8. Pulverulent, minerals which are powdery and have little or no cohesion. Properties and identification of minerals. Odor. Some minerals give characteristic smells when rubbed or heated. Types of odor. Arsenical, like the odor of garlic, for example, orpiment. Sulphurous, like the odor of burning sulfur. Pyrite gives a sulphurous odor. Argillaceous, like the odor of clay. Feel, it is the sensation of touching or handling minerals. The different types are greasy, soapy, rough, and harsh. Fluorescence, the color of minerals when exposed to sunlight or ultraviolet light. Green or colorless fluorite has a blue or purple fluorescence in sunlight. Phosphorescence, the property of a mineral to glow and emit light when placed in ultraviolet light. The glow may continue for a while, for example, diamond and sphalerite. Magnetism, the property of a mineral to attract to a magnet, for example, magnetite and pyrrhotite. The magnetite that possesses attracting power and polarity is called lodestone. Common rock-forming minerals. The most common rock-forming minerals are feldspars, quartz, pyroxenes, amphiboles, micas, olivine. They make up most of the Earth's crust, almost 90%. Feldspars, the most abundant minerals, making up as much as 60% of the Earth's crust. Feldspars crystallize from magma in both intrusive and extrusive igneous rocks as veins, and are also found in metamorphic rocks. There are two main types. 1. Orthoclase or potash feldspars contain potassium, KALSI 308. Found in acid igneous rocks, e.g. granites, etc., color varies from red, pink to white. 2. Plagioclase or soda-lime feldspars contain sodium, Nal-C308, calcium, Cal2C208, or both. Found in basic igneous rocks, e.g. basalt. Color varies from green, grey to white. 3. Some properties are given below: streak, white, luster, vitreous, cleavage. 1 perfect cleavage and 1 good cleavage that meet at nearly 90 degrees. Hardness, 6, moderate, harder than glass. Form, tabular. Specific gravity, 2.6. Quartz, second most abundant mineral in the Earth's crust after feldspars. Its chemical composition is silicon dioxide. There are many different varieties of quartz. Several are semi-precious gemstones. It is a very common ingredient in many rock, e.g. granite, sandstone, etc. Properties: color, colorless or white to milky white due to presence of impurities. Streak, white, luster, vitreous, cleavage, none. Hardness, 7. Fracture, conchoidal. Crystalline system, hexagonal. Types of quartz: rock crystal, pure quartz, colorless, rose quartz, pink, amethyst quartz, purple, smoky quartz, smoky gray. Pyroxenes. They form an important group of silicate rock-forming minerals found in basic igneous and metamorphic rocks. Different types are diopside, hypersthene, augite. Among these, augite is the most common mineral of the pyroxenes group. Its properties are color, greenish-brown or black, luster, vitreous, cleavage, good. 2 sets intersect at angles of 93 degrees and 87 degrees. Hardness, 5 to 6. Form, elongated prism. Fracture, most have uneven or brittle. Specific gravity, 3.2 to 3.5. Amphiboles, a group of rock-forming minerals which include 1. Tremolite, hydrous silicate of calcium and magnesium. 2. Actinolite, hydrous silicate of calcium, magnesium, and iron. 3. Hornblende, hydrous silicate of sodium, calcium, magnesium, iron, and aluminum. Among these, hornblende is the most common amphibole. Its properties are color, green to black, luster, vitreous, hardness, 5 to 6, cleavage, good. 2 sets intersect at angles of 124 degrees and 56 degrees. Form, elongated prism. Specific gravity, 2.9 to 3.5. Micas. 2 common varieties of mica: 1. Muscovite, hydrous silicate of K and Al, white and transparent. 2. Biotite, hydrous silicate of K, Mg, Fe, and Al, black mica. 3. Their physical properties are similar: luster, pearly, cleavage, perfect, hardness, 2 to 3, form foliated. Olivine is a silicate of magnesium and iron. Its chemical composition is magnesium iron silicate. It is a yellowish-green mineral. Thank you for watching this informative video. For more civil engineering knowledge, don't forget to subscribe and like this channel.